to talk about another way of transport which you see within the semiconductors, which is called diffusion, right? And we will first see what is why it is even arising, right? Why is the electron moving, which we say it's diffusion? Why is that so? And what is so different about it? Like when we saw, so last time we saw in another video where we had a lot of electrons which were there, let's say in N silicon, right? These are electrons are there, and we saw that the net movement of these electrons, though they have thermal energy, they are moving around, but the net motion of these electrons is zero because there is no net potential energy which is applied across. And to do that, what we did is we applied potential energy, and then what we started seeing that now, because the field is like this, electrons started to move like this, and then the current also starts to flow within the semiconductor. And this was what we said, this is due to a drift, because the electron, there is a drift which is applied by this force, the electrostatic force on the charge carrier, right? So this is a very straightforward way that we see that this is happening, right? Now, what is that if this condition is not there and you have a very different condition which we see all around us daily happening? We may know this is happening, this phenomena is happening or not, but it is happening, which is known as diffusion, right? A very simple way of understanding it, you know that when you are actually having in a room, you have, this is the air conditioning room, right? And this is your outside room, right? Or let's say the common room, right? So this is the common room, and this is your AC, which is your bedroom, right? So you have put the AC inside the bedroom, you have put in very nicely, you have closed all the doors, all the windows, and so that the control of the temperature is regulated, right, within this. So that means you can reach to a particular temperature which you are reaching in this particular room. Now what happens, suddenly somebody comes and opens this gate, right? And you start seeing that now AC, that to regulate this temperature is not very effective. And then you will see that this temperature, it starts to increase, right? So that means you have regulated the temperature, but for the same power, now the temperature, you are not able to reach the temperature, the lower temperature, right, which you want to reach. And now the question is, why is it happening? Why somebody opened the gate and then you are not able to regulate? What is that you are happening? So as a layman, I would think that this is happening, oh yeah, because I am not able to cool down the air. Now the question is, what is happening to the air? So when I cool down this air in this room, so air is at low temperature, right? So what is air? I think we all know air consists of some nitrogen, certain percentage of nitrogen, certain percentage of oxygen and other gases, right? Another molecules or whatever it is. So that is what is there in the air. So these molecules are at lower temperature when you are in the room. But as soon as you open this gate, what you see outside temperature is high. So what is going to happen? Suddenly you start seeing that, oh, there are other, this air which is the hot air little bit, and this is a cold air. The hot air will starts to move, and this is at an atomic scale, because you are looking at the molecules, right, which are going from there. So if you really want to see this phenomena, you have to look at the atomic scale, or how is the air changing, right? Or how the air from the outside is hot to cold, moving. But there are different ways to even look at diffusion. Like simply, let's say you have a coffee, you, and inside the coffee, when you have the hot quotient of the concoction of your coffee, and you mix some milk, and just look at what is happening. I think that is so beautiful to just look at. When you have a concoction of your coffee or your tea, and then you add milk on top of that, just beautiful the way it would start diffusing inside so that it becomes one with the concoction, right? And that's what give you a good coffee or good tea. So then this is a similar thing which is happening here, which is happening from high temperature. You see there is a molecules are moving to a lower temperature, right? Is this only related to temperature that this is happening? So then you can look at the analogy of the water where you have a tank, right? And this is connected to a bucket, right? A smaller bucket. Now there is a, in between there is a some switch. So this is filled. You see water is filled. What is happening? Why is the water not going there? Though there is a potential energy difference, you see water has from here to here. The potential energy difference is there, right? But still it is not moving. And it is because it is stopped by this guy. So what happens when you take off this thing, you remove this thing, what is starts to happen? You see that this water will now starts to flow, right? So what is happening? So even you can think of this even in a bottle, right, where there is no potential energies, because I'm just taking the case where there is no potential energy so that you can distinguish between the two effects, right, which way I'm going. So this is a bottle of water. There is a separation inside the bottle of water, right, which you can, let's say, put in like a pin or something. There is a water here and there's no water on the other side of that. As soon as you remove this pin, do you think the water would move? And you can test this, right? You can do this experiment and you will see that, yeah, water will start to move to this direction. Now the question, why is it happening? Because I don't have any potential, no potential energy difference. So then it cannot be drift, because if it was drift, then there would have to be a net force on the water or the molecules of the water, right? But here it is not there, because you just remove this, the membrane or the pin which you had, or the separation which you had, right? The separation was removed and suddenly you start to see that water start to flow. So what is happening? And that is what people studied, and it has been there for a long time, which is governed by, so mathematically or physically, this is governed by which we know as something called Fick's law, right? Where Fick's law says that the flux that it is moving from left to right, because you will see the water flow. Water flow means it's a flux, right? That is the water flow which you are looking at. It's proportional to the amount of water here and the amount of water here. So that is called as something as concentration gradient. So C is, let's say, the concentration of water here and concentration of water here, right? Which is dc, and this can be in any direction. For now, this is, let's say, x direction we are studying, right? So this is what it is. So then you would see, because there is a finite dc, if it was the case where there was already uniform water everywhere, right, then you would not see this happening, because everything is settled, right? So there is no flux which is happening. But whenever you have a concentration gradient here, or in the other case we saw temperature gradient, you would see that this starts to happen, right? This kind of thing starts to happen. Now you would say, what is that? How this, in this equation there is a temperature coming, because I don't see directly in that how that concentration and everything. So then you see the way it is moving, or the proportionality constant of this, is what is known as the diffusion coefficient, right? Because this is a diffusion effect, so this is called diffusion coefficient. So this diffusion coefficient is a very strong function of your temperature. Which can be seen as we were seeing the air example, that when you have, or you see, typically when you have a cold air which is moving at certain speed, but when you are heating it, because the particle now have thermal energy, which is what we saw, that the electrons, molecules have thermal energy. If the electrons are the ones who are moving around, or if in the air, it is the particles or the molecules are the one. They can move faster now because you have thermal energy. You have given thermal energy, which is what mean by that this thing, that because there is a thermal energy, so more thermal energy given to your particles which are moving, more diffusion coefficient, right? More diffusion and more diffusion coefficient, right? This is more diffusion coefficient. So this is the basic which you see in happening in real world about the diffusion, what is happening. Now let's go back to, after this understanding, I think it is going to be very easy for you to understand that what is happening in the semiconductor, right? So in the semiconductor, if I have an N silicon like this, where there is a uniformly doped electron concentration all side, right? And you don't apply any voltage and you are just measuring the current. Do you see any current? What would be the current? So first of all, yeah, from drift, because I have not applied any voltage, there is no potential energy difference. So that means from drift point of view, I can say, or I can just say no drift, right? And the reason is no PE difference, no potential energy difference, because you have not applied the voltage. Now, but we just learned that there is another mechanism by which things can move, which is a diffusion. Is there a diffusion here happening? So for the diffusion to happen, we see that there is some gradient should be there, because if all the electrons are uniform across, then it would not move, right? Basically, because there is no concentration gradient existing. So that means it would also have no concentration gradient. Gradient means there is no change in the concentration across the semiconductor because it's uniformly doped semiconductor. But you can say, oh yeah, I mean, if that is the case, can I create a case where what I would do is I would create more electrons here by some magic, and I will create lesser electrons here, right? Which can be thought of as that this is a very highly doped silicon, N++, and this is a low doped silicon. So that means there are more electrons which are there on the left side than right side. Now again, the question is, would you see any drift or current due to drift? No drift. What is the reason why no drift? No potential energy difference, right? So no PE difference, that means no force which is applied by the electric field. But when this thing is moving now across, would you see that there is a current which is happening? So this is not correct directly. So that's why I would not go into the drift, because when we create a gradient like this, we will see that you would tend to have a electric field which is resulting from this process. Okay, so that is something which we will discuss when we discuss junctions. But as of now, the main thing from this one can clearly see, if there is a concentration gradient, there is a diffusion which is going to happen, right? Because of the concentration gradient. So this is there. And because of that, you see your electrons will start to move there, because higher concentration to lower concentration. So when it is happening, and then you start to see there is a current which you will see because of that diffusion in your semiconductor, right? So that is one of the reason why would you see that in the semiconductor there is a diffusion. One of the important thing now of the temperature also, you can see, because you saw that when I increase the temperature, right? So you could see this like this, that what you did, rather than creating a case like this, but you created a case where you had N silicon to start with, right? So that means it was uniformly doped everywhere. But interestingly, what you did, rather than doping, what you did, you were heating this side of the semiconductor with a temperature T1, and this side of the semiconductor with some temperature T2. And T1 is much higher than T2, right? So this is hot, that you are attached a hot plate here, and you are attached a cold, some cold source here, right? So that means, which is like a thermocouple when we do. There's a hot, you have attached, then you have cold. So now because of this, what is going to happen? Is there any change in the concentration of the electron which I am feeling? Would I? So if you remember in semiconductor, what is the key about the semiconductor? That the N or P basically strongly depends on your whatever that variable is. Strongly depends on your T, right? So what you see is where the temperature is higher, your N1 is going to be much, much higher than your N2, right? This is N1, this is N2. And because of that, you will again see that there is effectively there is an electron which will move from left to right just by applying the different temperature at different sides of the semiconductor. So that is all about what is happening with the diffusion, and I hope you learned something, that this can be seen in the real life. We can do it in the also in the semiconductor. We can make junctions or these kind of conditions where electron move by diffusion, or sometimes we don't have a choice, that it would anyway move. And this is what we are going to discuss when we discuss different kind of devices. Happy learning to everyone.